Hello, my name is Steve Bowler, and welcome to the Juniper Border Gateway Protocol, BGP Lab number 4. In this lab, we're going to go over Route Reflector basics. So what I want to do is take a minute to talk about the basics of Route Reflectors, why you would use them, and what they help us accomplish within BGP. First, I'm going to describe our network diagram that we have in front of us. We have 4 routers, router 1, 2, and 3, which are in Autonomous System 100. Then we also have router 4, which is in Autonomous System 200. We are using logical tunnels to connect all of our routers together. Logical tunnels are used in this case in conjunction with logical systems. So all these routers are virtual routers, router 1, 2, 3, and 4, all in one physical Juniper router. If you're not familiar with logical systems, you can watch my Logical Systems Lab 1 and 2, in which I describe in detail logical systems, how to configure them, verify their operation, and why you would use them. Just real quick, I'll just tell you why you use them, and what we are using them for is the reason that logical systems allow us to have multiple virtual routers in one physical Juniper router. In this case, we have router 1, router 2, router 3, and router 4 that we have named, and we are connecting them all together via logical tunnels. And then what we're doing is we're running BGP on all the routers. So it allows us to do a lot of advanced routing and also MPLS and other protocols. So it gives us good practice if we just have access to one router. So that's enough about logical systems. If you want to watch, I have 2 videos on logical systems. I would suggest watching those if you're not familiar with them. The logical tunnels are LT-120.XX. For instance, on R1 to R2, we are using LT.12, and this is actually LT-120.12R12. The IP addressing is on R1. We have on all the interfaces, the .1 is used. Router 2, the .2, router 3, .3, router 4, .4. On router 1, we have interface loopback 0.1, which has the 1 network and the 11 network, both of those /24s. On router 4, we have interface loopback 0.4 with the 4 network and the 44 network, both of those also /24s. Between router 1 and router 2, we have the 12 network. Between R1 to R3 is the 13 network, and between router 2 and router 4 is the 24 network. We are running external BGP between router 4 and router 2. And then within Autonomous System 100, we are running internal BGP. We are peering between R1 and R2 via iBGP, and also R1 to R3 via iBGP. Router 1 we are going to set up as our Route Reflector. So what I'm going to do now is explain some of the basics of Route Reflectors. And what Route Reflectors allows us to do is bypass the iBGP, or internal BGP rule that every router that is running BGP within the autonomous system, in this case 100, must peer to every other router in the autonomous system that is running BGP. So there must be a full mesh within your iBGP configuration, and this is to alleviate and combat the issue of routing loops. So for instance, we all know that BGP uses the AS path attribute in its loop prevention and detection. But once you get inside your own autonomous system, the AS path attribute is no longer valid. So there is no way for these routers to have any knowledge of the exact information that it's learning via BGP if they are not fully meshed. And that's why you must have a fully meshed iBGP configuration. And that is what we're going to see, is that if we advertise some loopbacks, in this case on R4, we're going to advertise some networks from router 4 to router 2. Router 2 is then going to advertise these 4 networks to router 1. But then router 1 is by default not going to be advertising these networks to router 3. And this is because of the loop prevention mechanism that it creates by default within iBGP. So one way to get around this, there's actually 2 ways to get around the full iBGP mesh. One of those being route reflectors, and the other one is confederations. We're not going to talk about confederations in this lab. So the route reflector in this case is going to be router 1, and it has connections, and your route reflector must have connections to every other iBGP router within your autonomous system. And we see that that is true in this case for router 1. It is peering with R2 via iBGP and also to router 3 via iBGP. So it's kind of like the OSPF DR BDR on a broadcast multi-access network. All the routers report to the DR and BDR for accurate information. You can also think of it within OSPF as Area 0 has knowledge of all the networks and all the prefixes. So that is exactly what's going on. These routers, router 2 and router 3, are going to trust router 1, but they're going to be oblivious to the fact that they are indeed route reflector clients. We're going to see, though, that router 1, once we configure it to be a route reflector, which is very simple to do, we're going to see that right away there's going to be changes with the show commands that we do, and also how router 1 is going to pass the 4 and 44 networks to router 3. So route reflector is, again, this is one way to combat the rule within internal BGP that every router that's running BGP must peer with every other router. So this gets us around the full mesh rule. In this case, router 2 and router 3 aren't going to be talking to each other via iBGP, but they are going to be talking to the route reflector, which is going to be R1, and we're going to see router 1 is going to reflect these routes to the other router. In this case, we're going to see a route come into router 2, it's going to router 1, it's going to get to router 1, and then router 1 is going to reflect this to router 3. So I want to go through just the route reflector. I want to show you the route reflector basics before we get into some of the more advanced BGP labs that we're going to do, because you're going to need to know, and though we're going to see route reflectors in practice, so I want to just take a few minutes to go over route reflectors, the basics, how to set it up, what its purpose is, and then maybe we can do a more advanced route reflector lab down the line in another video. So let's go ahead, and now that I've explained in detail what we are doing in this lab and the network that we have running, let's go ahead and get into our devices. We'll go to router 1. Actually, let's go to router 4 first. And let's just do a show BGP summary. We can see that on router 4 we have a link to router 2. And that is an external BGP connection in AS100. Also, if we do the command show configuration protocols BGP, we see this is external. The group is eBGP. We're exporting our loop, which is... Actually, let's go ahead and do this real fast. Under R4, let's do a delete protocols BGP group eBGP export loop. Then we'll also do the command, let's do a show. We'll do a delete policy options, and we'll go ahead and commit that. So I left that in there from when I was practicing this lab, but I want to show you exactly what we're going to be doing. We're going to create a simple routing policy, export our loopback 0.4 interface into our eBGP. We're going to send that. We're going to send those prefixes, the 4 and the 44 network, to router 2. So let's go to router 2 and look at its configuration. If we do a show configuration, we see that under BGP we have the group iBGP. This is internal. We're doing export next hop self, which we explained to you in one of our previous BGP labs, the rule of next hop self. The peer autonomous system is 100. We are neighboring with router 1. Then we are also under our external BGP configuration. We are peering to autonomous system 200 and router 4. We go to router 1, do a show configuration. We see that we have under BGP, we have group iBGP, which is internal. The peer autonomous system is 100, and our neighbors are router 2 and router 3. If we go to router 3, do a show configuration, we have, well, let's do this. Delete protocols BGP group eBGP. Sorry about that. That's from another lab that I was practicing earlier. So let's get rid of that. We have protocols BGP group iBGP, type internal, peer AS100, neighbor is router 1. So this is where we stand. This is the initial configuration. If we go to router 1 and do a show BGP summary, we see that we have a link to router 1 and, router 2 and router 3. We're not receiving anything from either of those neighbors right now. So let's go to router 4, and the first thing we want to do, let's do this too. If we do a show BGP neighbor, I just want to do a couple of commands just to show you the local ID. This is our router ID, which is 1.1.1.1. We're going to set that, and we're going to see a best practice for route reflectors is to set the router ID as the cluster, under the cluster statement. And I'll show you that in a minute when we configure router 1 as the route reflector. So let's go to router 4. We're going to go ahead and create a simple routing policy. We'll do that. We'll do set policy options, policy statement. We'll just do loop. Term 1, from interface loopback 0.4. And once we match that interface with the from statement, we'll do then, which is our action. We're just going to accept that. Then we're going to go under We'll do set protocols BGP group eBGP, and then we're going to export our routing policy, which is loop. Let's go ahead and commit that on router 4. What we should see as a result, we should go to router 2 if we do a show route. We are learning the 4 and the 44 network via BGP. The autonomous system path is 200, which is router 4. So router 2 is learning the 4 and the 44 network, and it should pass this information to router 1. If we go to router 1 and do a show route, we see that we have access to the 4 and 44 network. So let's go ahead on R1 if we do a ping, 4.4.4.4, rapid count of 100. See that we don't have reachability, and that is because we are using, with that ping, we're sourcing it from our 12 network, which is the connection to router 2. But if we go to router 4, we do a show route, it does not know how to reach the 12 network. So the first thing we want to do on router 1, we'll just do let's create a simple policy on R1. We'll do set policy options, policy statement, direct. We'll do term 1, from protocol, direct. So we're going to match all direct, then we're going to do an accept. We will then go under set protocols BGP, group iBGP, export, and then we're going to export the routing policy, which is direct. So what this is going to do is we're going to advertise our directly connected interfaces into iBGP on R1. That's why we don't have reachability. Now if I do a ping, whoops. Let's do this. Let's go to router 2. Do a show route. We have the 1 network now showing up in the routing table, which is exactly what we wanted. If we go to router 4, let's do we have the 11 network and the 13 network. I apologize for that. What I wanted to do is source that ping from the 1 network. So if we ping 4.4.4.4 and source it from the 1 network, we can see that we have reachability. And that is, if we go to router 4 and look at the routing table, we now see the 1 network and the 11 network, which is off of our loopback 0.1, which was directly connected. We also see the 13 network, and that is what we are going to use later on in the lab for reachability for router 3 to get back, when it does its pings, to the 4 network. That's why we did on router 1. If we look at our show configuration, policy options, that's why we did from protocol direct instead of just from the loopback. We need direct because that's going to advertise in the 13 network, as we can see on router 4 as well, into BGP. So sorry about the confusion. And And so it appears as though right now router 1 has no problem reaching the 4 network, but if we go to router 3 and look at its routing table, we do not see the 4 network or the 44 network. And that is because of our rule that we were talking about earlier. A route learned via an IBGP neighbor, which was router 2 to router 1, is not sent to another IBGP neighbor by default. And that is, router 1 will not pass this route, the 4 network, to router 3. If we go to router 1 and do a show route advertise protocol, BGP, and then 13.13.13.3, that's to router 3, we can see that that is indeed the case. We are not advertising the 4 or the 44 network to router 3. If we go to router 2, though, which is directly connected to router 4, we do a show route advertising protocol, BGP, towards router 1, which is 12.12.12.1, we are indeed sending those networks to router 1, the 4 network and the 44 network. So what we want to do now is go and configure router 1 as our route reflector. The configuration for this is very simple. We'll go under Edit Protocols BGP. We'll do a show. And what we're going to see is that to configure router 1 as a route reflector, we're going to have to go under our group IBGP. We'll do the command set group IBGP. If we do a space question mark, we have the option for a cluster. This is the cluster identifier. And that's exactly the command that we're going to use to configure router 1 as the route reflector. So we're going to do the command set group IBGP cluster space question mark, and it's going to ask us for the cluster identifier. What I was telling you earlier, usually you set this as the router ID. So router 1, let's see if we can find out if we go to router 2 and do a show BGP neighbor. It sees the peer ID is 1.1.1.1, so that's the router ID of router 1. So we'll do the command set group IBGP cluster 1.1.1.1. We'll go ahead and commit that. And what I want to show you is the first thing. If I do a show BGP neighbor, we can see that right now our neighbors are being our neighbor adjacencies are being reformed. So if we do a show BGP neighbor, we can see that our adjacencies are now up. One of the most important things that we're going to see is that the state is established, and in parentheses we see Route Reflector client, where before when we did a show BGP neighbor we did not see that information. And on R1, if I do a show route advertising protocol BGP to router 3, this is the routes that I'm sending via BGP to router 3. If I hit enter, you can see that we now have the 4 network and the 44 network that we're sending. Let's go to router 3 and verify that. I do a show route. We now see the 4 and the 44 network showing up in the routing table on R3. If we do a ping to the 4 network, we have reachability, and also to the 44 network, we have reachability as well. So that's the basics of route reflectors, why you would use them, how you would use that, where you would use that. We saw that we used it on router 1, which router 1 had reachability to all the other BGP speaking devices or routers in Autonomous System 100. It allowed us, excuse me, configuring router 1 as a route reflector allowed us to pass routes that we learned via iBGP to our iBGP peers, because by default that is not allowed within internal BGP. Obviously for loop prevention reasons. So I wanted to get you familiar with the basics of route reflectors, how to set it up, because the next couple of BGP labs we're going to have a couple of route reflectors present, and so I wanted to touch on the technology of route reflectors. And like I said, I'll go back after I have done a couple more BGP labs. Maybe I'll go back and do another video on route reflectors, the next one being a little more advanced. So thanks for watching, and I hope to see you in the next video.